Hello everyone, welcome to this session. My name is Wycliffe, and in this session I will show you how you can monitor the health of your T field using Google Earth Engine in R. Tea can stay in the field for a very long time once planted, and you can find that there are so many farmers who are basically inheriting tea farms from their forefathers, and they are maintaining the production of such fields to date. So probably you are inheriting a piece of land and you want to monitor the health of that tea farm for a very long time, like maybe for 20 years or 30 years into the past. You want to see how the health of such field or such a field was. So we can do this simply in R. So we load uh, rgee library, and then we load SF library. We will also load dplyr library, right? And then we will clean some names. So we may need tidyr to tidy some names, and then we will visualize them using ggplot2 package. And finally, we will need some drawing. If you have the shapefile of your T field, then you don't need to draw any plots here. But for our case, we will draw some polygons around our T fields. And of course, we need to initialize our Earth Engine session using EE initialize, okay? So once that is done, we will draw maybe even two fields. So we can say our region of interest would be obtained by drawing features using map edit, okay? So after we've picked the draw features, we can pass it to, we can mutate a column which will contain the names of the fields. Let's say we want to draw, we want to monitor the health of two T fields. So maybe we are interested in field 1, and we are also interested in field 2. Okay. After mutating names, then we only pick that name. So you can say select name. After selecting name, then we convert this to an Earth Engine object. Okay, so I will expand this area, then we can see some nice T fields in Kenya and monitor the health of maybe two of them, these ones. Let me monitor this and this. So we can draw a region of a bounding, or we can draw a polygon around the two T fields. These polygons, you might have one for your own case study. You might already know the polygon or a shapefile. In my previous videos, I showed how you can import your own GeoJSON or shapefile and use in Google Earth Engine, okay? So once you are done that, you click done here, and then you have your region of interest as an Earth Engine object or a feature collection, okay? So once we have the region of interest, then we can center our object around that. We can center our mapping around that. Center object, where the Earth Engine object is the region of interest, and the zoom level, let's say we zoom it at a level of 18 because those are very small fields. And then we can visualize the two fields. So map $add layer. And then the layer we are adding is an Earth Engine object called region of interest, but we style it. So we styled it such that the color is, say, yellow, and then the fill color is transparent. So transparent color here is given by hash 123456000. Okay, so that's transparent. And then we can add width so that they're a bit visible, a width of, say, 2. So if we run that, we zoom to our two T fields and we can see them. So we are assuming that these are your two farms. You are a farmer and you want to know how their health has been over time. Or you want to buy them and you are concerned whether the person is selling to you healthy farms over time or they have just improved the health of the farm when you went to buy it and later the farm deteriorates. So let's say you want to monitor it for maybe 23 years. So we can have a start date of 2020, January 1st, thanks to Landsat image, which goes back to 1999. And end date is maybe 2024, January 1st. So that is up to 2023. Okay. So over that period of time, we want to get our Landsat 7 image. Okay. So we will use Landsat 7. So we will go for an image collection. That's an image collection. And in this image collection, we provide the ID of the image. If you go to Google Earth Engine Coding Editor, you will find clearly this ID belongs to Landsat 7. So we'll use collection number 2. Collection 2 and tier 1 level 2. That is T1L2. Okay. And then after taking that image, we will filter bounds, and that is only to remain with scenes that intersected with our region of interest. And then we filter date so that we only have images there for the start date. Sorry, we don't need that in quotation because we've already defined it. Start date and end date. Okay. After filtering for the date, then we can map a function. So the function we are going to map here is one that cleans the images for cloud cover and also masks out the saturated bands. Okay. So we can create a quality assessment band, which is from each image in this long list of collection. We pick the quality assessment pixel. Okay, so it's denoted by QA pixel. And then we use it for masking. So that is bitwise and then we pass integer number 31, which can be binarized, and then we get those that are equal to 0. Okay. Then for the saturation, that is for cloud cover. For the saturation, we can call it SAT. Basically almost the same thing. So I can copy that. And then for the QA pixel, we talk about QA RADSAT. RADSAT. Okay, that's the band for correcting for saturation. And for that, we only equate to 0. Okay. And then we are only interested in the optical bands because we want to do an NDVI. So we can say our optical bands are from each image, we only select all bands that start with SRB, SR underscore band, then everything. And we multiply those bands. I should go back and show you all these values, but it will take us a lot of time. So 4 zeros to 75. This is the scale which we use to convert the pixel values to, or to bring down the digital numbers to reflectance values, and we add the offset of negative 0.2. Okay. So after scaling, after picking our optical bands, we can then say our image will be the image, but then we add bands. The bands we are adding to it are our optical bands. And then we set null and true in adding the bands. So we just add the bands alone. After that, we update mask twice. So we update mask with our QA, and again, we update mask with the update mask with the SAT, with the saturation, okay? Then now is when we can calculate our NDVI, which we say from the image, get normalized difference. Let me expand this a bit so we see clearly. Normalized difference, and the bands which we are going to use here are the SR band 4, that is the near infrared band, and SR band 3. Remember, this is now Landsat. So in Landsat, band 4 and 3 are the near infrared and red bands, respectively. And we can rename our image as NDVI. And to this NDVI, we need to append some information, which is we copy properties from the original image, and the properties we are copying here is only system time start, which we pass as a list. System time start, so that should work. Now we have a clean Landsat image, so we just need to map it over years. Here we have all images, but now we need annual images. So we can create a list of years, which is Earth Engine list sequence from 2000 to 2023. Okay. Then we can then create annual images, which you can say annual NDVI gets years. We map a function, and the function we map is EE utils by function, this one, and that takes a function which grabs year. After taking year, then it is converted to a number. So year becomes Earth Engine number, converted the year to a number. And then what is the start for each year? The start for each year is Earth Engine date, $, from year, month, day, the year itself, and then the first day of the month. And then what is the end? Let me expand this. The end is the start, but we advance it or we increase it by 1 year. Okay, so that gives us the temporal dimension or the time period within 1 year across all our images. So it will be grouping collections for each year together. Okay, so to get an annual image, we will take our Landsat 7, which we had prepared before, which we have cleansed before, and then we filter it, or we filtered it from start to end. That is for each year in that mapping. Okay. After picking that, we can get the mean NDVI for the year, and we rename it as using Earth Engine string, because when we get a mean for the year, then we lose the naming or the names of the bands, and then we can add year to this NDVI. So we cut year, which we need then to format so that it doesn't have trailing zeros or numbers. It doesn't become a float, but it's considered an integer. Okay. Then after that, we now have annual image, which we can set year to. Annual image, and then set year, which is just but the year. There is a problem somewhere. Let's see the problem. Years, could not find years. So maybe we didn't run this. Could not find function years. Okay, then let's look at it. Years $map, like that. Yeah, so then we need to remove this. Perfect. So once we have the annual images, that's a list of images. We can convert it to a feature collection, or even directly to bands. We can say annual bands is equal to, how did we call it? Annual NDVI. So at engine image collection, $ from images that NDVI, and then convert it to bands, as simple as such. So what we have here is an image with several bands, okay, whereby each band is for 1 year. That is the start to the end of 1 year, okay? Then we can then clean the names of these images, because when we use two bands, it assigns numbers to the names. So we can say the old names were the annual bands, $band names, band names. Those were the old names. And now new names or clean names will be the old names, but then we map an Earth Engine util spy function, which takes a function that grabs a name from that list, and then after taking the name, it replaces the numbers. So casts the string to the name and then replace everything that is between 0 and 9. Anything between 0 and 9 and an underscore, plus an underscore, replace it with nothing. So that is remove them. Okay. So if you look at old names, let's confirm this, that old names, if we say get info from them, you will see numbers like 20, 21, 22, 23, right? There is a problem. We wanted this to start from the year 2000 all the way to the year 2023. Okay, here. So this one should be from the year 2000 to the year 2023. Like that, like that, like that, like that, like that. Okay. So I was wondering why it started from 2020. So if we go again to this and get the information, we will see from 0 to 1000 to 2023. So these are the numbers in the old names that we don't want. And if you check the clean names, then we don't have those numbers. If we get info from that, then you can see now we have done away with the numbers in this simple regular expression, which picks any digit number plus an underscore and replacing it with nothing. Okay, that is removing it. If you replace it with nothing, then you've removed it. Okay, so we can then reduce regions or extract the values and put them in a stats object. So we can say stats takes the, oh, we've not renamed our bands. So these were the annual bands. We can say annual bands clean. Then we take the annual bands and then we rename it by using clean names. Okay, so these bands are now having the names without numbers. Then we reduce regions because we have a feature collection to reduce around, and the collection is the region of interest, which are the two farms. And then the reducer we are using here is to get the mean NDVI for each year within the farm, and then at what scale. We want to use the native scale because these are small farms. Okay, so this one is an Earth Engine feature collection which contains NDVI values, annual NDVI since 2000 for the farm. Now comes one of my most favorite stages of this, which is about converting this feature collection to simple features or an SF object. So we just use EE as SF, and then we pass stats like that. This might take some times because it's it's even faster than I thought, because it's around 23 images that it's doing extraction on, and it's getting the mean for each of these for the two farms. Okay, so after converting it to an SF object, then we may need to, you can have a look at it, no problem with that. It's a wide format data, which has got NDVI values for field 1 and for field 2 from the year 2000. That was field 1, field 2, field 1, field 2, 2001, up to 2023, field 1, field 2. And the fields are polygons. So these are simple features object which you probably are familiar with. Even more familiar is the data frame. Okay, that one was SF. Even more familiar is a data frame. So the data frame, we take the stats SF, and then we drop the geometry, ST drop geometry. This we get from SF object, from SF package. Okay, simple features package. Then finally you can have a look at it. It's still the same as the other one, but now no geometry, no polygon aspect. We've dropped that, but we have the fields and we have the NDVI values for each field. Okay. Then comes another interesting part where we now clean our image better. So we can call it a data frame. So data frame gets stats DF. And then after taking it, we pivot it longer, because once it is longer, this is now where we call the tidy R. So the calls, we don't need name, so we leave name alone, but we say names to, we take the names to maybe an object called year metric, a column called year metric, and then values to, we can take them to a column called NDVI. Okay, so if you look at that, we have already pivoted our our data frame to something more tidier. So now we have NDVI and year, and then we have the NDVI itself. So we need to split this to have year and NDVI as separate objects. So we pass it to separate, just the same as the verb says that we separate. So we are separating year metric, because it's the year metric which contains the word NDVI and the year. So we separate it into what? We separate it into two things. Number one, into some form of prefix, which will be the NDVI, and also year. Okay. But what is the separator? We separate them at the underscore. So outside the underscore, on either side of the underscore, we want some value. Then we are separating a character. So both NDVI and 2000 will be characters. But under the year now, we can pass it as an integer. We can coerce it to become an integer because they are numbers, although they are considered character because they originated from character. Then what we select is only name, which is field 1, field 2. And then we also select year, and we also select NDVI. We are not interested in the metric or the prefix, okay? If you wish, you can also arrange them by name and year so that they are a bit well ordered, like this. So that gives us name and year is now an integer and NDVI value for all our years. Okay, so we can save it into DF and then we use ggplot to visualize the trend or the health of this. So we pass DF and then the aesthetics, we will use X. On the X-axis, we will put year. And on the Y-axis, we will put NDVI. And then we will group by name. So because we have two names, we have field 1 and field 2, and we need to color them by the same name. So there will be color for one group and color for another group. After that, we can use geomline to show the trend in health between the two fields. And then we can also add points to yeah, is not found. Okay, so you can already see how the two fields, the health of two fields has been performing over time. Okay, then yeah, you can add a lot of improvements on this your plot. For example, you can provide better labeling on the x-axis. For example, you can say x is here and y is NDVI and DVI, and then you can add title as field 1 NDVI. Okay, so you can say fields 1 and 2 NDVI or health or productivity, whatever you are trying to infer with this 2000 to 2023. Okay, then you can put, give it maybe the minimal with some good base size plus the minimal with a base size of maybe 14. Cool. So that is how the health of the two fields has been progressing over time. So if somebody is selling you their farm or if you are inheriting this farm, or if you want to know the history of this farm in terms of health, then this can be a good way to monitor. And you can even ask questions around 2006, what happened to the farms, both of them, or was there a serious drought around this period of time? And what changed from 2015, 16, 17? From 2017, probably something better happened, or the fields were replanted with another greener field or something, or more. It's now under new management with grandsons or sons or something like that, who are taking better care of the fields or something. The field has been improving since both fields. But generally, field 2 is healthier than field 1. I have no idea whether these two fields, they're basically the same size. We could even calculate the areas of each easily. So that's what I wanted to share in this. I didn't want it to be too long. You can visualize the NDVIs in the final script I'll share. I will put some mapping of the two fields, like map add layer, so that you can see the NDVI values for each year. And if you want, you can export the NDVI for all the years, all of this. All of these clean bands, you can export them to local. In my previous videos, I showed how you can export an image to your local drive and do any other further analysis you may wish within R. Okay, so if you find this useful, kindly share it with your colleagues or enjoy using it. And cite the sources of data you use accordingly, and even the packages you're using, because people really do a lot of work to create these packages that we enjoy using. And it's just a good practice to say thank you by citing them accordingly. The link to this script I will leave in the description section of this video, so you are free to go to my GitHub and pick the whole directory or the whole repository, which will contain 30 scripts by the end of November. So you can use all those as you wish to learn rgee. Thank you and happy coding. Bye-bye.